Learning Outcome 2, Algebra and Equations, 12.2.4. Factorize third-degree polynomials, including examples which require the factor theorem.
How am I going to do this?
Did you say something, Debo?
Well, sort of, just talking to myself.
Really? About what?
About this question on my worksheet. I don't know how I'm going to do it. It's just beyond me.
I don't believe that. I'm sure there isn't anything you can't do. Maybe you just need me to point you in the right direction. Let me just see.
Sure.
Okay. This is a third-degree polynomial or cubic function, and you have to factorize it. By the end of this lesson, you should be able to factorize cubic function using the factor theorem.
Okay, then so where do we start?
We start by looking at what we call the factor theorem. The factor theorem says that if f of b divided by a is equal to 0, then ax minus b is a factor of f of x. Simply put, if we substitute the x value of the divisor into the function and the remainder is 0, then the divisor must be a factor of the function. In order to factorize a cubic expression, we first need to look for a common factor. If there is no obvious common factor, then we use the factor theorem to find a factor. We substitute by trial and error different values for x until we find one that makes the expression equal to 0. So if the x value equals a, then x minus a is the factor. Are you ready to put the factor theorem into practice?
I'm ready to give it a try.
Here's an example we can start with. Firstly, we know that in order for x minus 1 to be a factor of the expression, it must go into the expression exactly. In other words, according to the factor theorem, if we substitute the value of x into the expression, we should get an answer of 0. The factor theorem says that if the x value equals a, then x minus a is the factor. If we apply that to our example, we can say that if x minus 1 is a factor, then x must equal 1. I can then substitute this into the expression wherever I see x and simplify. And I get that f of 1 is equal to 0, which tells us that x minus 1 is a factor of the polynomial, since it goes into the expression exactly without a remainder.
That makes sense, but how does this help us to factorize a cubic function?
Let me show you. We can use this example again. We have just found that x minus 1 is one of the factors of this cubic function. All that is left for us to do now is to find the rest of the factors, and we will have factorized the cubic function.
Hey, that makes sense. I didn't think about it that way. But how does it help us find the other factors?
We can actually do this quite easily by inspection. In grade 10, you learned that a cubic function is given by a binomial multiplied by a trinomial. We've already found one binomial factor, so all we need to do is find the trinomial. In order to do this, we would first need to find the a value and the c value by inspection. By inspection, I can see that if I multiplied x in the first bracket with x squared in the second bracket, I would get the x cubed in my original expression. So a must be 1. Using this method, I can see that minus 1 must be multiplied by minus 6 to give me the positive 6 in the original expression. So c must be equal to minus 6. All we need to do now is find the value of b, which is only a little bit more difficult. If I wanted to find the x squared term in the original equation, I would have to expand the brackets and collect like terms. Specifically, I would have to multiply the second term of the first bracket with the first term of the second bracket, then collect this with the first term of the first bracket multiplied with the second term of the second bracket. In this case, minus 1 here multiplied by the x squared here, added to x here, multiplied by bx here. We know that these must add up to a negative 2x squared, which gives us an equation from which we can calculate the value of b. In our example, b would be equal to negative 1, giving us a trinomial, which we can then factorize in order to find all the factors of the cubic function. I just want to note here that if there are no x squared terms, we can still use this method to find the b term by comparing the x terms.
That's not really as difficult as I thought it would be. Can I try one on my own?
Sure, here's one for you. Factorize x cubed plus x squared minus 9x minus 9.
I think I can do that. Hold on, how do I find the first factor? Last time we were given the factor.
I'm afraid you're going to have to use trial and error. In other words, you're going to have to substitute different numbers into the equation until you find one that gives you a zero remainder.
But that means it could be anything.
Not quite. The constant will give you a clue as to the possible factors. In this case, the number will have to be a factor of 9. What are the factors of 9?
The factors of 9 are plus or minus 1, 3, or 9. So one of these will give me 0 if I substitute them into the expression.
That's right.
I'll try 1 first. If x is 1, then I substitute 1 wherever I see x. Then I simplify and I get that f of 1 equals negative 16. So 1 isn't a factor. Let me try minus 1. If I substitute minus 1 wherever I see x and simplify, I get 0. So x plus 1 is a factor. Now for that hard part, finding the trinomial.
Go ahead, you can do it.
All right, I know now that x plus 1 is a factor and that this is a cubic function, which means that the factors are given by x plus 1 multiplied by a quadratic equation. To find x cubed, I would have to multiply x by x squared. So a is 1. To get negative 9, I'd multiply 1 by minus 9. So c is minus 9. If I multiply out the brackets to go back to the cubic function, I would have to multiply x in the first bracket with bx in the second bracket, and 1 in the first bracket with x squared, and collect them to get the x squared in the cubic function, which means that b must be 0. Is that right?
Yes, that's right. And if you substitute that into the quadratic, we get the difference of two squares. Do you remember how to factorize the difference of squares?
Sure. X squared minus 9 factorizes into x plus 3 and x minus 3.
You've done really well today, Teboho.
Thanks so much, but I suppose you're still going to give me an extra task to do on my own for homework.
You suppose correctly. Here is an example for you to try on your own. The next step is to take what we have learned a bit further. We will use the factor theorem to help us solve a cubic equation. Actually, I have a bit of time now if you'd like to give it a try.
I'm willing to give it a try.
Good. Let's have a look then. By the end of the lesson, you should be able to find the roots of cubic equations. Before we start, can you summarize for me what you learned the last time?
For sure. In the last lesson, we used the remainder and factor theorems to help us factorize a cubic function.
Now, we are going to use the exact same technique to factorize the expression and then give the roots. This is a very important section of work because you will use it again later when you study calculus. As you know, we can represent all equations as graphs, and a cubic function is no different. The graph of a cubic function would look something like this. And just as in quadratic equations, when we solve for x in the function, we have to find the x-intercept or the roots of the function. If we take a close look at the graph of the cubic function though, you will see that in this case, there are 3 intercepts with the x-axis. This means that we need to find 3 solutions for x. With this in mind, are you ready to get started?
Yes, let's do it.
Great. Let's start with this example. Given 6x cubed minus 5x squared minus 17x plus 6 equal to 0. Solve for x.
That looks just like the cubic function we worked on last time.
You're right, but before we continue, I'd like to go back to something quickly. We know from quadratic equations that if we have 2 factors multiplied together and equal to 0, then either factor could be equal to 0. It follows then that if we have 3 factors multiplied together which equal to 0, then each of the factors could be equal to 0. So, in a cubic equation, in order to solve for the unknown, we would first need to factorize and then solve for x, in the same way we do for quadratic equations.
I think I can handle that. We learned how to factorize a cubic function in the last lesson.
Off you go then.
First, I need to find the factors of the constant. The factors of 6 are plus or minus 1, 2, 3, or 6. Then we substitute each of these into the expression until we find a factor of the equation by trial and error. I'll try 1 first to see if it's a factor. If I substitute 1 into the expression and then simplify, I get negative 10. So x minus 1 isn't a factor. Let me try 2 this time. I substitute 2 for x, which gives me 0. So x minus 2 is a factor.
Good. And what's the next step?
Next, we need to find the other factors. We know that a cubic function is a binomial multiplied by a trinomial. We already have a binomial factor, so we need to find the trinomial factor.
And how do we find the trinomial?
We can find the trinomial by inspection. We know that one of the factors is x minus 2. In order to get a cubic function, we would need to multiply that by a trinomial, which we can write as ax squared plus bx plus c. Which means that to find the other factors, I need to find the values of a, b, and c in the trinomial. I'll start with a first. X times 6x squared gives me 6x cubed. So, a is 6. Minus 2 times minus 3 gives me 6. So c must be minus 3. To find b, I multiply the first term in the first bracket with the second term of the second bracket, which gives me bx squared. Then I multiply the second term of the first bracket by the first term in the second bracket, negative 12x squared. If I collect these, they must give me negative 5x squared. So if I solve the equation, I get that b must be 7.
Good, Deboho. What do you need to do now?
All I need to do is factorize the trinomial. I let each bracket equal 0 in order to find x.
Excellent, Deboho. Do you think you can manage another one?
Yeah, I think I'm up for it.
Okay. Give this one a go. Solve for x in this equation.
Let's see. The factors of 4 are plus or minus 1, 2, or 4. I'll try 1 first. No, it isn't a factor. Okay, I'll try 2. 2 doesn't work either.
Why don't you try a negative number? Maybe negative 2.
Good idea. If I substitute in -2, it gives me 0, which means that x plus 2 is a factor. Now I need to find the trinomial. The first term is x squared, because x times x squared gives me x cubed. The last term is positive 2, because 2 times 2 equals 4, and I represent the middle term as bx for now. X times bx is bx squared, and 2 times x squared is 2x squared. If I collect these, I need to get the second term in the cubic function, which is -2x squared, which means that b must be -4.
Well done, Deboho. What's the next step?
Next, we need to factorize the quadratic. But something isn't right here. The quadratic doesn't seem to factorize.
That's all right. Do you remember what you need to do if the quadratic doesn't factorize?
Don't we use the quadratic formula?
That's right. Why not give it a try? You can leave your answer in the simplest third form.
Looking at the quadratic function, I can see that a equals 1, b equals -4, and c equals 2. If I substitute that into the formula, I get x equals 2 plus root 2, x equals 2 minus root 2, and x equals -2.
Excellent, Deboho. You've really got the hang of this, I think.
Yeah, I think I'm getting the hang of it, but also think I might need some practice so that it sticks in my mind.
All right, I'll give you some examples for practice.